And you see the share?
Yes, the floor is yours, Thomas. Thank you.
Okay. So thank you for the opportunity. I've never done such a presentation like this, so it's a first for me. It will be really interesting. So this is about VIC NX, which is sort of a redo of the VIC20 mainboard, but it's expecting it to be fully compliant, compatible. It will be a PowerPoint presentation since it runs code, but the video output is still lagging, so it's not much to see in that respect. All right. So this is the agenda. I will have a little bit of who I am, projects, backstory of this, what is it, fair amount of technical details about the compatibility going forward, and then there might be a question or two. Okay, so me, I'm 57 years old, wife, 3 kids, living in south of Sweden. I have been an electronic engineer for the past 40 years, and now I'm working as a consultant on a number of assignments. To Advenica, I do military-grade encryption systems. I do a Raman spectroscopy instrument for detecting chemicals, typically narcotics, explosives, and warfare agents. I also am involved in a toilet seat that used a radar and machine learning to, with integrity, let the nurses know what has happened to avoid any medical problems. And then, of course, I have my own products, mostly the VIC20 retro stuff, and also a 65C816 computer. I just want to mention that I hear roughly the bandwidth of any 8-bit computer. So it's up to 4 kilohertz, and then it's totally dead. So if you have any questions, please shoot them to Sebastian or in the Zoom meeting chat. That would be much easier for me to understand it. Thank you. Okay, so it started with the PET 2001, my trip with computers. And then I bought myself a VIC20, a used VIC20. After a while, I upgraded to the Commodore C128D. And then it has been PC and now Mac from that time, except, of course, I own, I think I now have 6 VIC20s of different variants. So, all right, I still think that the 6502 is sort of meditative and still king. It lacks in performance. It makes up in ease of use. You have the data sheet, the programmer's reference, tips and tricks, as well as errata in roughly 30 pages. The last board I did on a Linux board, the technical reference manual for the OMAP from Texas Instruments was 19,743 pages. I think there was like 40 pages just on how to set up the boot pins. So it's just for fun and sort of relaxation projects then. So I do quite a fair amount of things for my VIC20s, a fair amount of memory expansions. I have a drop-in replacement for the 6560, 6561 I'm doing. I have as pictured here, I use for my Commodore 64s and the VIC20 a USB to the DIN adapter for powering them. And then the topic of today, the VIC20, the VIC NX. So the backstory here is that I did my own variant of this, but with a mechanical keyboard built into one PCB. But that didn't really fly well. The ergonomics was really poor. I didn't expect that you really wanted, although a keyboard has an angle, it's not much, but still having a flat mechanical keyboard was very, very unsatisfying. So I got my hands on some empty bread bins with keyboard in excellent condition from a guy in Denmark. So I thought, well, why don't I then make a compatible keyboard, motherboard? So what is it then? First of all, it is, as I started, it's a work in progress. But it is a VIC20 reincarnation. It's done with modern SMD parts, except of course for the main 40-pin parts. It has full memory expansion. And for you who know about the VIC20, it's block 1, 2, 3, and the cartridge 8K. That's fully read-writable, of course, and you can write protected also for ROM emulation, sort of. In the VIC20, the block 0, the first 8K, has a cost-reduced hole in it of 3 kilobytes, which was never populated, but it has been populated here. And that is also accessible by the video chip, which is a difference from the stock board. Another difference is also that there are 2 I/O blocks. They are called block 2 and 3 with RAM. That is also accessible by the VIC. And then there is 32 different images of kernel and BASIC, so you could have Jiffy DOS or whatever you like. There's a permanent S-video output. It has the style of connector as the C64C DIN connector. And I have also remedied one of the drawbacks of the original design. I have added in a true UART that can be switched into the user port, so it should be transparent, but will allow you to have, I think it would actually run up to 1 megabit per second, but I guess there are other constraints in the system. It has also extended the color RAM, and it had an integrated meatloaf, which is a fantastic add-on for Commodore computers. It attaches an SD disk and Wi-Fi to the IEC, the serial disk interface. So, and here is a still picture of the current version of this. And the rear panel is updated. It has USB Type-C for power. It also has a reset switch and a power switch, obviously. It has the same joystick and paddle as stock VIC20, but it has been moved a little bit upwards. And then you have the SD card for disk, any ordinary SD card up to 32 gigabytes or so. There is also a new driver for the top LED in RGB, and that's because it shows a little bit status if this is in maintenance mode because we bricked some the machine, and if it is transmitting through Wi-Fi or accessing SD card. So it has some information. That's the only thing that is sort of really apparent when you switch it on. All right, a little bit deep diver here in the heart of the thing. We have a CPLD that handles all the memory management and memory decoding that used to be in the stock VIC20 done by 74 LS series of logic, basically. We have 512K flash then for the 32 banks of kernel and basic, including the configuration software that we need. All right, and then we have video circuits and all the RAMs. We have the multiplexers for the UART and U-support, and we can also have a 65C02 in the machine if you want that. And here is the meatloaf part of it. All right, some details. The main components are the DIPs, 4 of them. The rest is quite ordinary surface mount devices, nothing too crazy. There is a microchip CPLD that is fairly used in these projects. The UART, and then there is a small green pack programmable analog digital circuit for all the housekeeping, reset and power, mostly. Yeah, I think this can. So if we compare it to a normal VIC20, we have a normal mode and we have a configuration mode. They are have access to the same memories except the first 8K, which is separate, so it can have some and the configuration software doesn't have to care about whatever kernel and the basic use for memory. And the main difference actually is here. It is in the block 0 and the block 4, which is the IO area. Orange is RAM, so we can see that the VIC NX has almost full 16K of video RAM, except for where the actual IO part at $9,000 and 1K upwards are located. You can also then notice that this is a ROM in the VIC20, but we have RAM for the character generator here at 8000 to 8FFF. Black is ROM. So how does that work when you switch on the computer? So after reset, the green pack will actually sort of start the system with a hidden firmware that does a bit of checking if you have certain conditions on the keyboard pressed, and it will also read any configuration and so forth, and also read in the character ROM and write protected if need be. All right. The accessing to adding the UART and the control configuration registers is a potential compatibility risk. The VIC20 has an extremely simplistic decoding of the IO unit, so they are repeated over and over in this 1K. and I have squeezed in where it is possible the UART in configuration. However, a program that doesn't really behave could make this non-workable. That is one of the problems. And it comes from, as we will see, the simple decoding. Goal is, of course, 100% compatibility, but there are some pitfalls. We use modern parts together with old parts. Timing can always be an issue. And we have this reset extra sequence that might be a problem with certain modern cartridges that might depend on the timing during the reset. But I don't think it should be an issue, and there is a mitigation plan for it if it should be. The insertion of the extra register is probably the one thing that could be an issue. I have chosen to decode the addresses completely, but any program that doesn't really behave or writes or makes use of the fact of the simplistic decoding could corrupt everything. So let's see here. It works like this in the VIC20. It has two vias, two parallel interfaces, and it is decoded as a base address, and then it just uses if A5 is a 1 or A4 is a 1, it selects the different vias. Now I have chosen then to use 00, so it shouldn't be activated, but famous last words. The same goes for the chip select of the VIC chip. Here. It has also a fairly simplistic, it is repeated all over 256 bytes. It only uses 16 of them. And it is a totally different part of the VIC20 that selects or deselects it. Okay. So my last 2 minutes here going forward. Get everything up and running. Today the system runs the code, it generates interrupts, it seems to be working, but there is no usable video for some reason. It is coming out something, but it's not a workable video. Then, of course, we'll verify everything with a reasonable pick of difficult software. NTSC would be a trick for me since I live here in Poland. There is some firmware being needed. And if there is interest, then we will, of course, apart from setting it up as open source on GitHub and so on, I might be making a run of all the SMD parts, and you just have to supply the 4 DIP circuits. And in that case, we have to go through regulatory testing and declaration of conformity here in Europe. Okay. And if there is any question.
Good, many thanks, Thomas. Let me see if I think for attendees in the call, if you have any question, just unmute yourself and.
Yeah, I mean it's just a mail away, so.
Yeah. Otherwise, in the meantime, maybe I have one. So you mentioned the Meatloaf integration. Is it so that you re-implemented it, or did you expand it, or how does that?
It is for the time being. It's a straight implementation of what is available on the community. But since I have it on board, sort of, I am actually thinking about having a parallel bus directly to the well, the inner of the board, so it will set up through the ISE channel, and then with some, I don't know what to call it, warp speed over the 8K blocks. But for now, it's straight on implementation of what's available.
Okay.
So it's a fantastic piece of hardware.
Yeah, definitely.
Meatloaf, you know, really nice community also.
We had Jamie presenting here in this one of these events here some time ago. The Meatloaf for the Commodore 64. Yeah. But then back to the hardware part. So you said, yeah, okay, it's up and running, but it's not generating any video. How do you testing?
So I have a logic analyzer, basically, that where I record everything, and then of course I have uses oscilloscope to look at the video output, and it's really it is something there that resembles video, but it's a bit garbled. So, and then you always have the problem with these very old chips that you never know if it actually is the chip itself that is broken. So I will try to steal it from one of my other machines and see if I can, if that is the problem. So, but it seems to, all the logic part of everything seems to be working. So.
Okay.
All right. That's, thank you for your time. And thank you for inviting me, Sebastian.
Well, many thanks to you again. So I will just stop the recording now.